Well, first of all, I really want to say how exciting it is for me to be here today, because 2 years ago, this same conference, the Symposium Mammographicum, was the first ever conference I've ever attended. So it's an honor to be here. My name is Roberta, as you've heard. I'm a statistician for the Policy Research Unit in Cancer Awareness, Screening and Early Diagnosis, based at Queen Mary University. And my presentation today, it's an evaluation of the NHS breast screening program in England. Our research question was to see if the program is still effective in reducing mortality from breast cancer. As I'm sure you all know, 1988 was the year when the first women were invited to screening within the NHS breast screening program. And this followed an evaluation of several, this happened after an evaluation of several randomized controlled trials. And the ones listed here are the ones that appeared in the Forest report that led to the establishment of the program. And in the last 30 years, there have been major improvements in terms of treatments and diagnostic techniques. Within our department, a few years ago, a case control study to evaluate the NHS cervical screening program was set up. And this led to a change in policy for what concerned age at first screen and screening interval. So following its footsteps, we set up to do the same thing for the breast screening program. And this paper that is shown here, it's the same paper that Professor Andy Evans mentioned yesterday in his talk. This was the pilot phase of our study, which only used data from London. And it showed a reduction in breast cancer mortality of 39% for women who attended screening at least once. So we moved on to the national phase of the study, which has data from all of England. And this is what I'm going to present to you today. So because it was a case control study, it is a case control study, our cases were selected as being women who died of their first breast cancer in a 2-year period, 2010-2011. And these women were diagnosed when they were between 47 and 89 years old. Controls, as you may expect, were instead women who were alive. And they were matched to their corresponding case based on age and where they had been screened. And we selected 2 controls per case. A quick slide on the data collection. Data from our cases came from the National Cancer Registration and Analysis Service database, which we accessed through the PHE Office for Data Release. And the controls instead were identified by our colleagues at NHS Digital through the National Health Application and Infrastructure Services System. It took me a while to learn that. The last slide on methods before we move on to some results. Case control studies on screening are subject to a type of bias known as self-selection. This is based on the assumption that if you are a woman and you receive an invitation to a breast screening appointment, if you decide to take up that invitation, it is more likely that you are more health conscious and therefore healthier. And this results, well, it is more probable that this will result in a better outcome of your screen. So this gives a bias in favor of screening. Sorry, something funny happened with the slide here. So it's a bias in favor of screening, which we adjusted for using a method by Duffy et al., for which we had to look at how many women in our data set had ever had a smear test, had ever attended cervical screen. Finally, here are some results which are still preliminary at this stage. After doing some exclusions based on the criteria that we set in the protocol, we ended up with about 8,000 cases and 15,000 controls that had similar demographics. And this is our primary endpoint result. So we used a conditional logistic regression with the fact of ever being screened as the exposure. And this gave us an odds ratio of 0.49. before we adjusted for self-selection. After we adjusted for self-selection, we ended up having 0.62, which is equivalent to saying that if you attend screening, breast cancer screening at least once in your lifetime, you will see a 38% reduction in your chance of dying from breast cancer. The last result that I'll show you today, it's what happens when we divide women into 3 categories, age categories. And we see what happens to the odds ratios as the time since last screen increases. The most interesting result is what happens to older women, aged 65 or more, which are represented by the purple line at the bottom. For this line is the only one that never crosses the red horizontal line at 1 of non-significance. That means that breast screening has a significant protective effect for these women over time, at least up to 5 years since last screen. To sum things up, our results show that the breast screening program is still effective in preventing death from breast cancer, and its protective effect seems to be lasting longer for older women. This latter thing in particular is important in light of what we heard yesterday about the recent incident in the breast screening program, because these women may now be getting a delayed screen, but because they are the women represented by the purple line, the fact that they're getting a delayed screen only now may actually entail less risk than it would have been the case for younger women. Our team is also working on evaluating the effect of the NHS breast screening program on breast cancer incidence, on quantifying the impact of overdiagnosis, and we're going to look at the interplay of early detection, stage, and treatment on fatality from breast cancer. Last but not least, I really have to thank all of my colleagues at Queen Mary University. My colleague Dharmishta Parmar is a senior data manager of the studies here in the audience if you happen to have any questions on data collection and data management. We also are very grateful to Rachel Brennan and David Graham, to the Department of Health, and to all the patients and the NHS staff without whom this study wouldn't have been possible. And thank you all for listening.